Early, then early. You see, because this is if early, then early. So early, then early. You can even you can even start to read it from right to left now. Because you see, early, if early, then early. You see, because that happened first. You see those letters there on the right side happened first, because you see early after early, late after early, early after late, late after late. So if early, then early, early, then early. Okay, early, then early. Early, then early. Early, then late. If early, then late. Early, then late. What about this one? If late, then early. Late, then early. Okay. Late, then early. And then now the intersection symbol you have to use. And this one is late, then late. Okay. And to calculate the probabilities now using formula number 5, because that's what we have. E given E times E. L given E times E. Okay. E given E times E. So you just multiply. You might see that in a YouTube and they'll just tell you multiply along the branch to get the outcome. Just multiply along the branch to get the outcome. But that is the reason you're multiplying, because you're using formula number 5 for intersection. Okay, so you don't just multiplying because of independent. You know, and this is and there, and is multiply, or is plus. It's not because of independent you multiplying, it's because of this formula for conditional events, events that happen in sequence. So please bear that in mind. So what you expect the formula here to be, anybody? E intersect L will be equal to P of what? P of E, L given E, right? Look at there. Times E, isn't that so? L given E times E. And here it is. Okay. E given L times L. Right, exactly, doesn't matter. So even though you have L given E up there and E given E down there, doesn't matter. Okay. And you just multiply. And another note that you must take into consideration, that all those 4 probability values must add up to 1, and exactly 1. So along the branches across any node, across any node must add up to 1, must add up to 1, must add up to 1. All the outcomes, here you have 4 of them, must add up to 1. Okay, so this is what you do for number 12, assignment D, part A. Okay, it says to construct a well-labeled tree diagram. Now you have 2 questions, follow-up questions. To answer the follow-up questions, you must use the outcomes. I repeat, do not go back into the tree to answer the follow-up questions. Please do not go back into the tree to answer the follow-up question. To answer the follow-up question, you have to use the outcome values. These are the values you have to use to answer the follow-up questions. For example, it says, what is the probability that Bob arrives to work late on both days? All right, this is a sentence, words, both days. Both days can be symbolically represented. Which symbol here represents late on both days? Which one signifies late on both days? Anybody? These is values that you have to use to answer the questions. Don't go back to the tree. These and that. Part B says late on both days. Okay, let me just make sure I'm recording. Right. Late on both days. Which of these saying late on both days? Probability of late on both days. The last one, late then late, exactly. Late on both days, late on a Wednesday and late on a Thursday. You can even use the word and too, watch it. Probability of late on a Wednesday and late on a Thursday. Late then late on both days, 0.03. Okay. So if you go into the solution, you will see directly that the answer is 0.03. The probability that Bob arrives to work late on both days can be obtained directly from the tree, which is denoted as P of L and L, 0.03. Okay? And at C now, it's a, what is the probability that arrives to work late on a Thursday? Late on a Thursday. Which of these, which one or more than one that communicates late on a Thursday? Hello? You have 1, you have 2, you have 3, and you have 4. Late on a Thursday. Why number 3? No, number 4. Number 4 is late on a Thursday. Is number 4 alone not late on a Thursday? Number 4, and now you have to be very careful with your words in probability analysis. You see number 4 and number 2. You think it's the word and we should be using there? Think about it. You think that's the word and we should use there? You think it's then we should use there? You think it's then we should use there? Then is a symbol, then is times. And is times. Then and is the same thing, you know. Oh, exactly. And think about it. Think about it in the real life. He can come to work late this way by first coming to work early, isn't that so, on a Wednesday? Or he can come to work late like that twice, isn't that so? This way or that way. And what is the operation for the word or we said already? What's the symbol for or? Adding, plus. Okay, so he can come to work late on a Thursday either that way by first coming to work early on a Wednesday, or he can come to work late on a Thursday by having coming to work late on a Wednesday. So you see all that information that can be gathered from that simple tree. That is the simplest tree. Okay, and this is a very useful tree when you're planning. You want to open a business, you want to have a project, you want to build a bridge, you want to build a skyscraper. You have to take into consideration all possibilities. So you have to make contingency plans for if in case, you hear the word if that happened, what to do. Okay, so this is very useful, and you might see that in business, in persons that you know, doing a course, you have quantitative business, quantitative decision making, you know, for when you want to open a business and you want to take into consideration all possibilities and so forth. You want to do an investment and you need to, you know, what if that happened, what to do, and you know, so you may see that tree diagram for those that want to venture into business. Okay, the tree diagram. So try to get a firm grasp of it. All right, so let's just check part C, the or, And as you can see, we can anticipate we're going to add those two values there. This way or that way. Two ways that he can come to calculate on a first day. And here it is. Right, 0.33. But is that early or late? So let's look at the question again. Oh, early on a first day. Oh, so that's why. Okay, so what we just discussed there is late on a first day. That's okay, that's okay. What we just discussed is late on a first day, but then the question say early on a first day. So probably that's why one of the students said it could be this way. So this is the early on a first day, so we can just rapidly apply it. Early on a first day is 0.33 plus 0.23, okay? And late on a first day, so the rectangle is early on a first day, okay? So let's bear that in mind, rapidly, early on a first day, this way or that way. So that's why in the example, remember early on a first day, you have 0.33 plus 0.23, okay? So please apply that to the question. We first analyze the late on a first day, so that's why we circled 0.41 and 0.03, but the question say early on a Thursday, so it's 0.33 plus 0.23 to give us 0.56. So please apply that to number 12 in the assignment.